Sir, can you see my screen now?
Yeah. Yeah, physics, you have current electricity, DC circuits, practical electricity, simple magnetism, force on a conductor. So they are writing the unit of books, textbook, right?
Yes, sir.
So that one is federal physics. That is called federal physics, right? That one.
Yes, sir.
Okay, that one is green color, right? Cover is green
Um,
color. That one.
no, sir, we haven't done that yet.
Sorry.
We didn't do it. Like, sir, we were supposed to do it, but then we did not have time, so
No, no.
we
I'm
couldn't
saying
do it.
the cover of the book is green color, right?
Oh, yes, sir. Yes, sir.
And that is a course for O-level physics. Charles Tew. The author is Charles Tew, right? Your textbook.
Sir, we don't, sir. Our physics are uses a different textbook than us. So he shares the screen of his one,
Okay,
and then
so
he send
how?
us like this ones
Yeah, so
from
you
here.
you don't have the textbook your own.
Sir, I have my own textbook. Yes.
So your textbook, what is the name of the textbook? Can you send me the cover page in the messenger?
Okay, sir.
In the messenger.
Okay, okay, sir. Sir, I've sent you the cover.
Yeah. Mm, oh, this one. David sang one, right?
Yes, sir.
So, is it the syllabus you are showing that's from this book unit?
No, sir.
These kinds of unit we have in federal physics book. You see, I have the book. I can see there is written. Can you share the syllabus again?
Okay, sir.
Yeah, it's like unit 18 current electricity, then unit 19 DC circuits, unit 20 practical electric circuit. Exactly same way it's written, the units in this book, Federal Physics. That one I was saying, course for O-level physics by Charles Chew.
Okay, sir.
And it is, I'm also sending you the cover page of that book and the chapters, units, you can understand. So he is
Okay, sir.
following this book. This book
Yes, sir.
is available everywhere in Bangladesh, in our country,
Okay, sir.
and mostly the students are following this book. Okay, this one. Just a minute. Mm. You see, I sent you the images, the cover page and the topic's name, unit's name. You are showing me those are here exactly same way, right?
Oh, okay. Yes, sir.
Yeah. So he is following this book anyway. So tell me now in our coaching we are doing unit 18, right?
Yes, sir.
And also we did simple magnetism. That one we did. That is actually on topic 17. We did magnetism and electromagnetism. That part. Then no, nothing else. Then so current electricity we are almost done. We did Ohm's law, then experiment on Ohm's law. We have done
Ohm's
with
law.
most of the things in current electricity. Then DC circuits, we have only few things. We have circuit symbols. Then we have potential divider rule. These two are most important thing over there. The series and parallel circuit, their advantages, their disadvantages. All these things are there in DC circuits. Practical
Yes, sir.
electric circuitry, we have fuse, circuit breaker, then live wire, earth wire, then switch. How can we connect them? Where we should connect them in live wire? Why we are connecting them in live wire? All these things are in practical electricity, and we have some electrical hazards, like we have damaged insulation, we have heating, overheating of cables. Then we have dam condition in practical electric circuitry, right? And we have also energy calculation. The unit of energy is kilowatt hour, right? In
Yes,
practical
sir.
electric circuitry, all these things we have. Then we have simple magnetism. We did topic 17 is simple magnetism. That one we did. That's only magnetism, okay? That is simple magnetism. Like we have basic magnetism ideas, then permanent magnet, temporary magnet. Their examples, their uses. Okay, how can we magnetize? How can we demagnetize? Then we have magnetic screening. All these things are in simple magnetism. Then
Yes,
unit
sir.
22, we have force on a current carrying conductor. That's bringing the idea of um, we have right hand grip rule, right? So that
Yes, sir.
one we are using for force on a current carrying conductor. We have two wires together. Then if they are carrying current in the opposite direction, they will be attracting, right?
Yes,
Because
sir.
of right hand grip rule. This way we have some applications over there. Force on a current can be, and last we have on this Fleming's left hand rule, and depending on Fleming's left hand rule we have motor, uh, DC motor application, that is
Yes, sir.
working like Fleming's left hand. We have arm for uh, motion of the coil. Then we have current direction, we have magnetic field direction, right? First figure
Yes, sir.
or first figure is for magnetic field, second figure is for current, then thumb is for force. This way we are having Fleming's left hand rule, which is used for DC circuit, DC motor. Okay, the
Ah,
motor
sir.
effect we are getting, that is from this topic, unit 22. Then in unit 23 we have generator, and for generator we have Fleming's right hand rule. Fleming's right hand rule, we are getting EMF, induced EMF, right? If
Yes, sir.
we move a magnet in a loop, then we have electromagnetic effect. Or we are moving a wire in magnetic field, that time also you are having induced EMF, right?
Yes,
Isn't
sir.
it? So in both cases, you can move the magnet or you can move the wire. There should be motion. If it is not moving, then there is no induced EMF. What is the basic idea? The magnetic field line should be cut with the coil. Then there will be induced EMF. And magnetic field can be cut if there is motion, right? Isn't it?
Yes, sir.
So when there is no movement of the coil or no movement of the magnet, you will not see any induced EMF. So it is the condition for induced EMF that there should be motion of the magnet or motion of the current carrying motion of the conductor, right? That can be copper
Yes, sir.
wire. Okay, now in this effect, electromagnetic effect or induced EMF, we are having electricity from kinetic energy, right?
Yes, sir.
And in motor we are getting kinetic energy from electricity, opposite, right? In
Yes, sir.
dc motor we got kinetic energy from electricity, and that is Fleming's left hand rule. In
Yes.
generator we got Fleming's right hand rule,
Fleming's right hand rule.
and here we are getting electricity or induced EMF from the motion, right?
Yes, sir.
From the kinetic energy, just opposite. So here we are having generator, and we have here AC generator. In AC generator we have a graph. At last we have a graph, and as it is alternating current producing, then we have positive and negative EMF, right? And there is
Yes,
a
sir.
sine curve. We have got one sine curve. The upper part is positive EMF and the lower part is negative EMF, and we can link this graph with the AC generator induced EMF, the rotation in different positions of the coil. The coil is cutting the magnetic field lines in different way, and depending on that, we have more EMF, we have less EMF, and sometimes we have even no EMF, right? That's why the
Yes, sir.
that's why the graph is sinusoidal graph. You see, the at the beginning it's starting getting increase, then it is decreasing, then it is becoming zero, again it's increasing, right, in opposite direction. This way the graph is
Yes, sir.
working. So that's about electromagnetic effects and introduct. And other than this AC generator, we have also transformer. In electromagnetic effects, we have also transformer. Have you got transformer?
Um. Yes, sir. We got transformer, but I did not understand what was it.
Okay,
Yeah, I
I
didn't.
will make you understand. No problem. Transformer is working with induced EMF idea. Like we have Fleming's right hand rule for induced EMF. That idea we are using in transformer. And here we must need alternating current. Without alternating current, we cannot make transformer. What is the function of transformer? Transformer is used to make the voltage lower or upper according to our needs. That's why it is called transformer. Like in our house, we need 240 volt, and in the main supply, you see in the street or in the cables, we are having the cables grid lines in the street. That one might have 5,000 volt or 10,000 volt, right? So
Yes, sir.
we don't need that 5,000 or 10,000 volt. We need 240 volt. That's why we are changing this 10,000 volt to 200 volt, 40 volt. So that is called step down transformer. Okay, what is called
Okay, sir.
step down transformer? And for step down transformer, in transformer we have coils. We have two types of coils. One is primary coil, another one is secondary coil. Okay, so in
Okay, sir.
primary coil we are always giving the EMF, right? Have you got
Yes,
it?
sir.
In primary coil, we are giving alternating current or alternating EMF. That one uh, is inducing EMF in the secondary. If the number of turns is less in the secondary, then induced EMF will be less than the primary. Like you have, for example, I'm making it simple for you. Like you have 10, 10 turns in the primary. How many?
10 turns.
10 turns in the primary. And in primary, you have, for example, 2400 volts. How much?
2400.
2400 volts. So in secondary, uh, how many turns you need to have so that there will be 240 volts? In primary, how many turns I told?
10.
10. So number of turns in the secondary should be only 1, so that your induced EMF will be here only 240 volt. That is we need. Is it clear?
Yes, sir.
So this way, this is called step down transformer. Like in primary we have more voltage and secondary we have less voltage.
Less than 10.
Okay, this is called step down transformer. And we have power station. In power station, the the EMF we are producing, that one is, maybe it is 2000 volt. Okay, but in grid line we are giving 20,000 volt. How much we are giving in grid line?
20,000 volt.
20,000. So you are getting in the power station 2000. You need to make it in the grid line. Why we need to make more voltage in the grid line? That one has more explanation. I will tell you now, later after discussion of this step down. Step up
Okay.
we are discussing now. So when we have 2000 and we have to make 20,000, then number of turns in the primary is less and number of turns in the secondary will be more. Like in number of turns in the primary, if you have 50, then number of turns you should have 500, right?
Yes, sir.
So that from 2000 volt you can have 20,000 volt. Is it clear? And that is called step up transformer.
Sir, I
So
didn't understand the step
yeah,
up.
step up transformer. Why is called step up transformer? Because
So
from
that we can.
2000 to 20,000 we made, right, voltage.
Yes, sir.
And how we made it? Like we have number of turns 50 in the primary. Primary is in the power station and secondary is in the grid line. Okay.
Yes, sir.
So if primary we have 50 turns, number of turns of the wire or cable, then in the secondary how many turns should be?
50 turns.
50
10
multiplied by
turns.
10, right?
Yes, sir.
500 turns. Now you understood?
Oh, yes, sir. Yes, understood.
Because we want to make 10 times the voltage, we want to make 10 times, so our number of turns of the coil should be also 10 times.
10
Is it
turns.
clear?
Yes, sir. Understood.
Okay, this is called step up transformer.
Okay.
So from power station to grid line, we are using step up transformer, and from grid line to our house, that one we are using step down transformer.
Down transfer.
So why we are making the voltage higher in the grid line? That one has explanation. Like you uh, already know that if the cable line is longer, if it is a longer line, then there is long path to travel. The long path, the electrons are experiencing uh, huge resistance, right? isn't
Yes, sir.
it? And when there is resistance experienced by the electron, then it's producing heat energy, right?
Yes, sir.
So if heat energy produced, that means your electrical energy is lost as heat energy, right?
Yes, sir.
But we want the electricity to use for other purposes. And now uh, to reduce this heat loss, we have two quantities. One is voltage, another one is current. For power supply, we have one equation: power equals V into I, right? Voltage into
Yes,
current.
sir.
So the power we are getting in the power station, uh, we will get the same power in the grid line and the same power in the domestic house, our house. Okay, now if the power, for example, I'm giving a small example, that if the power is, for example, 200 watt, then your uh, voltage is uh, 10, and current is how much?
Sir,
Hello.
sir, 50.
uh, the the power I said
Oh,
how
sir,
much?
20, 20.
Yeah,
Sir, the
200
power
I
is
said.
200.
So it is 20, right?
20.
then
Yes, sir.
then your current is 20 ampere. It's a very big amount of current, right? Now this amount of
Yes, sir.
current, it goes through the grid lines cable, then it will produce a huge heat, right? So
Yes, sir.
what we do, we increase the voltage, like we are making the voltage 20. Okay, then how much will be the current? 10, right?
Yes, sir.
So when the current will be 10, then it's less heat is produced, right?
Yes, sir. This is.
That's why in grid lines we are giving higher voltage. I gave you only a very small example. Actually, the voltage is made even bigger, like 20,000 volt. That time the current is very less. Then there will be very small amount of heat lost. Is it clear?
Yes, sir. Clear.
Okay, so that's the reason why we are using step up transformer and making the voltage bigger, so that in grid lines we have less energy loss in the form of heat energy. Is it
Okay, sir. I
clear?
understood. Yes,
So
sir.
this is the idea about transformer. All about transformer, but now you have to understand from the diagram how the transformer is working, and how the induced EMF is produced from primary to secondary. That is very important point. Without diagram, you cannot understand it. So let me check. Uh, you have any diagram of transformer in your notes? Like sir is giving you any notes, or he is
Y-
only
yes,
explaining?
sir. He's giving. Sir, he's giving notes.
Okay. So what type of?
Wait, wrong.
These are from electronics. This is circuit.
Um,
Yeah. After this, go down. You
so it's
you
not
have
going
more
anymore.
notes.
No, sir.
This
I
is
think so. It's this much.
only this practical electricity. Then this one, Can you go here? Magnetism and electromagnetism here. Let's see if there is anything.
Okay, okay, sir.
Here only, yeah. Here we have right and grapefruit. Then here. Wait. Little bit up here. Let's see. Is there anything here? Okay. Force on a current carrying conductor. Yeah. So go down. This one is from DC motor.
Yes,
Here you see left hand rule. Fleming's left hand rule.
yes, sir.
Go a little down. Yeah. After that, there might be transformer because here is generator, right? DC motor. Here DC motors.
No, sir, it's done.
Done, right?
Yes, sir.
So here, this one, yeah. And in generator, we are using slip rings. In generator, we use slip rings. In DC motor, we use split rings. These split rings, you have some, space over here that is called split. That means the ring is splitted. So this is
Yes,
about DC motor. And the generator one, you will not get this type of split. That one is slip rings. That is called slip, SLIP. Okay.
yes, sir. Okay,
So
sir.
that one is not shown here. Your generator part is not here shown. Only the DC motor is shown. So you did not get anything more from electricity notes
No, sir. We
from
only got
sir.
this much.
Can you check with sir that he he is going for that one electro the transformer one, the AC generator one, that is electromagnetic effects. Is he going with that one?
Sir, I've asked him like to give all the notes and writings he gave, so he gave me this four.
So we got here till DC motor. After that, even electronics is not there, right?
Yes, sir.
Transducers. Here some applications of electronics part. And
Sir,
also
can you
you.
explain me the DC circuit? I didn't understand that.
This is a. When is your exam? Physics exam?
Um, sir, it's on the 20th. I mean, no, sir, not in the 20th, on the 9th.
Ninth.
Yes, sir.
9 means this week. We have this
Yes,
week.
sir.
9 means maybe on Wednesday,
Yes, sir.
Sunday. Yeah, Wednesday. Yeah. Okay, DC circuit. In DC circuit, we have you see um, this potential difference. Right?
Yes, sir.
You know all the circuit symbols, right?
Yes, sir.
And you know about series and parallel circuit
Yes, sir.
and advantages of series circuit. You know,
Yes, sir. We also have the
yeah.
notes.
What is the advantage of the parallel circuit?
So, advantage of parallel circuit is that the battery will last longer.
No. That one is for cells are connected in parallel. That one, but uh, like if you are using lamps in parallel circuit, then what is the benefit?
Sir, the
That one I told you that cells are connected in series or parallel. Then how we are getting the benefit? But DC circuit is saying you if we are connecting the components, not the power supply. The one you got from
oh
me that is
yes,
about the power supply. If it is connected in series or parallel, what benefits we are getting? And here we are talking about the components like lamps we are connecting in parallel, or any other components we are connecting in parallel, then what is the benefit?
Sir,
You see, it's written here. One thing, in a parallel circuit, each component uh, connected uh, also applied to resistors with different values has the same potential difference across. That means in the power supply it has 6 volt, each of the lamp will get 6 volt. Is it clear?
oh, yes, sir.
So when they are getting 6 volt, that means they are getting complete energy from the power supply, right? And
Yes,
the, the lamps will glow if we are using one lamp, the way it glow. If you are using multiple lamps, they will all glow brightly. Is it clear?
yes, sir. Now I
So it
understood.
is advantage of parallel circuit. Another advantage is if one of the lamps is uh, cut, like lamp 2 is cut, then still lamp 1 will work. Okay.
Okay, sir.
Why? Because here we are getting the circuit complete, right? So it will work. Is it clear?
Yes, sir.
And
Yes, sir.
whatever the advantages you are getting for a parallel circuit, those are disadvantages of series circuit. Can you show me series circuit
Yes, sir.
here? uh, Series circuit, go on. This is also parallel. Yeah,
Sir,
this
here.
one, this one, this one, just go up. Yeah, here. Okay, so what is the disadvantages of series circuit we were talking? I told you that in parallel circuit what are the advantages we got. In series circuit those are disadvantages. So the first one I said, all the lamps they will glow brightly in parallel circuit,
Yes, sir.
right? So in
Yes, sir.
series circuit the lamps will be dimmer. Why?
Because there are no current for it to.
No, there is current, but the voltage, for example, we are giving a 6 volt, then this voltage is shared among the lamps. Like
Uh,
L1 it will get 3 volt and L2 it will get 3 volt.
3 1. Okay, sir.
Okay, that's why the lamps will glow dimmer.
Ye- Yes, sir. I understood.
And another one we said that if one component in parallel circuit we got that if one component breaks, then other components still work, right?
Yes, sir.
So disadvantage of series circuit is if one of the lamps is cut or breaks, then other lamps also disconnected from the circuit, right?
Yes, yes, sir.
So
But in parallel, it is.
yeah, it still work.
Yes,
It
sir.
is in work. So this way series and parallel are working, and we have also some advantages of series circuit. What is that advantage?
Sir, they
Like
flow in the same. The current flow in the same
yeah,
throughout
that
the
is
series.
that is actually not the advantage. Advantage is we can use a single switch. We can use a single switch to operate all the components. That is advantage. Okay.
Yes, sir.
So parallel circuit that will be disadvantage. For parallel circuit we are using different switches, right?
Yes, sir.
For different components. In series, as there is a single path, so we need less wiring, right?
Yes, sir. That's why.
But in parallel we have branches, so we need more wiring, right?
Yes, sir.
So you got the advantage and disadvantages, right,
Yes, sir.
of series circuit and parallel circuit disadvantage. So what are the advantages of series circuit? Those will be disadvantages for parallel circuit.
Fair,
Have
sir.
you got it?
Yes, sir.
And
Understood.
that is property. What you said, that is property of series circuit, that everywhere the current is same in the circuit because there is a single path here, right?
Yes, sir.
And in parallel, current is divided into branches, right?
Yes. Yes, sir.
So so in parallel we have voltage same everywhere. In series we have current same everywhere. Okay.
Okay, sir. Understood.
So about series and parallel we are done. Then after series and parallel we have potential divider rule. We already said you that in series circuit we have this one 6 volt, then each of the lamps will get 3 volt, right?
Yes, sir.
So potential is divided, potential is shared over here, right?
Yes, sir.
So this way we can also get uh, the potential difference according to our need. Like some of the components, for example, we have here 6 volt, but the component we are using here, that one we require only 1 volt. Okay,
Yes, sir.
that time we are using a special type of circuit that is called potential divider. Okay, potential divider circuit. And uh, how it is working I'm showing you. You I'm annotating here.
Okay, sir. Sir, stop sharing. Sir, can I come from the washroom?
Yeah, sure, come back.
Yes, sir. I'm back.
Okay, so the notes I gave you there, we have DC circuit idea, you see.
Yes, sir.
We have nodes of current, electricity and DC circuit together. So if
Yes,
you
sir.
scroll down here, you will get them. Uh, we have, okay, till here, light dependent resistor. Till here, we have this part is current, electricity. And from the circuit symbols, we are having this DC circuit. Okay, all the circuit symbols are here. So series circuit, parallel circuit we discussed. You see, series and parallel circuit at a glance. This there is a
Yes, sir.
table, you can understand it easily, like current, same current flows through all the components in series circuit. A different current flows through each component in the circuit. Voltage, series circuit voltage is different potential difference that means shared, right?
Yes, sir.
Then parallel circuit potential difference exists across same, right?
Yes, sir.
And this way you can find advantages, disadvantages also here given. You can find. Now potential divider circuit, what is that? Like uh, we have one component, one motor, that one requires 5 volt. How much requires?
5 volt.
5 volt. So we want to have an arrangement uh, where we will get the 5 volt output in the component. For example, here we have 6 volt. The power supply is how much? 6 volt, right?
6 volt.
And
Yes, sir.
we are making the series circuit with 2000 ohm and 10,000 ohm resistors. Okay,
Okay,
and
sir.
2000 and 10,000, the ratio is 5 is to 1, right?
Yes, sir.
So this resistor, we know that in a series circuit, the power supply, the voltage we have or EMF we have, that one is shared, right, among the components. So 10,000 ohm and 2000 ohm, they will share 6 volt according to their resistance. Okay, so
Yes, sir.
10,000 ohm, this one, if we think this one is R1 and 2000 ohm, this is R2, then we can use the formula to find the output across 10,000 ohm. That is uh, labeled as V1. For example, V1 equals R1 by R1 plus R2 multiplied by V. Okay, here V is 6 volt, then R1 is 10,000, R1 plus R2 is 12,000, so 10,000 by 12,000 multiplied by 6 is coming 5 volt, right?
Yes, sir.
This is called potential divider circuit. And this potential divider circuit is used in many places. Uh, According to our need, we are placing it. Okay, like you have fan, right? Sometimes we are increasing and decreasing the speed of the fan in our house. We have one regulator, right?
Yes, sir.
So how we are increasing or decreasing the voltage? This way, potential divider, using the potential divider. If we want to increase the speed, then we get the output voltage greater. Okay, then fan is connected across here 10,000 ohm, then the speed of the fan will be more. If you want less speed, what we do, we connect the fan across 2000 ohm. Okay,
Okay, sir.
this way we can change, right?
Yes, sir.
This is simple example I gave, but there is little more advanced technology now we are using, that is called potentiometer or variable potential divider. Like we are using a slider, we are using only one resistor and we are using the slider, that one can be moved from uh, bottom to the up so that the resistance can be varied. You saw yesterday in Ohm's law, did you see rheostat?
Yes, sir. Real estate.
So the rheostat, that one we use the uh, sliding, right? We can
Yes, sir.
increase and decrease the voltage, or increase and decrease the resistance. According to that, the voltage is increasing or decreasing, right?
Yes,
Isn't
sir.
it? So the same thing is happening here. We are having the shared voltage according to our need. Okay, like if you want both both of them are working with 3 volt, then your resistance you can fix here 5000 ohm and 5000 ohm, right?
Yes, sir.
Then each of them they will share same voltage. Is it clear? This is called potential divider rule. Okay,
Yes, sir.
so that's all about DC circuit. We have potential divider at last. So you got the idea, right? And if you want to get the output across 2000 ohm, like that one is V2, right? So your
Yes, sir.
R2 will be 2000. Then calculate what is coming V2. Check. Is it coming 1 volt?
Yes, sir. One.
So it matches, right?
Yes, sir. It matters.
So the formula works. This way we are using potential divider. We have some questions about potential divider rule in our worksheet. Then you'll understand more. And I saw even your worksheet has some applications of potential divider. So can you go there, please, in your worksheet,
Okay, sir.
electricity
Okay, sir.
worksheet? Then I can show you.
Sir, can you see the screen?
Yeah, yeah, I can see. So here you go up little bit, little up, go. Here I saw one diagram, resistors are in series. Here. Wait. Stop and think. This one. Wait.
Okay, sir.
The diagram shows an electric circuit. What is the current at point X? So everywhere the current will be same, right? This is
Yes, sir.
application. Okay, go down. Check where is potential divider rule.
Here, sir.
Yeah, potential dividers. Now you understand. Go down. You see, it's written here potentiometer also. Yeah, here is sliding, right? Sliding
Yes, sir.
contact of potentiometer. So if you are moving up, then you are getting more resistance, right?
Yes, sir.
And more resistance means more voltage will be shared in the output. Okay.
Okay, sir.
If you are going down, then you are having less resistance. That means output voltage will be less. So this is called potentiometer. The way we are increasing or decreasing the speed of the fan, the regulator, it is called regulator, right? So that is
Yes, sir.
potentiometer, one type of potentiometer. Okay, so now you understood potential divider and potentiometer.
Yes, sir.
If we are using fixed resistors like the 2000 and 10,000 ohm we use, that is called potential divider. And if we are using sliding contact, that is called variable potential divider. Okay,
Okay, sir.
because we can vary it, right? That one is fixed,
Yes,
but this one we can vary. So variable potential divider, in short, it is called potentiometer. Have you got it
okay, sir.
now?
Yes, sir.
Okay, then go next. Yeah, wait. I told you that there are some applications in uh, potential divider. You see, this one is the example. If light dependent resistor, can you please read here?
Okay, sir. If light dependent resistor LDR is used as the variable resistor, the light intensity will change the resistance of the LDR, which will in turn vary the potential difference across the LDR.
Okay, so here light dependent resistor, you know about this. This is depending on light, its resistance decreases, right?
Yes, sir.
If resistance decreases, that means it will share less voltage, right, than before.
Yes, sir.
So this way we can use this light dependent resistor to operate the street lamps. eh, and also we can use the intruder alarms using the light dependent resistor. At night time there is dark, right?
Yes, sir.
So when one intruder will come, he must will use the light, right?
Yes, sir.
And when the light is falling on the circuit in the light dependent resistor, that time you will have less voltage over here, right? The resistance
Yes, sir.
decreases this side and less voltage here, and that time the alarm is connected in the other resistor. The output will be then this side, okay, upper side. That means that side voltage will increase. If voltage increase, that means current will increase, right?
Yes, sir. Fine.
So when current will increase, then that time the bell will ring. We can understand that there is someone in our house, right, or in our surrounding area, right?
Yes, sir.
So this way the potential divider rule is working. Have you understood?
Yes, I understood now.
Okay. Okay, thank you so much today. And you go through your doubts, all the things, and also you communicate with your teacher that the electromagnetic effects and introductory electronics, those are in your exams or not. We can see here
Okay, sir.
till uh, the force on a current carrying conductor, till that much we have. Can you go to the syllabus?
Okay, sir.
So look here, 18, 19, 20, 21 till 22, the notes and worksheet we got there, but we did not get anything from unit 23 and unit 24. So you ask your
Okay, sir.
teacher, uh, is these two units are coming in the exam or not?
Okay,
Okay,
sir.
then you
I'll ask him.
report me. If needed, then we can have another class tonight, no problem. Okay, you
Okay, sir.
just inform me. Thank you so much.
Okay, sir. Oh, thank you, sir, for teaching me.
Okay, Allah Hafiz. Assalamu alaikum.
I love, sir.